Hey, let me ask you something interesting. What if the biggest battery breakthrough for electric cars isn't new chemical formula, isn't faster charging, isn't even solid state batteries? What if the real breakthrough is this? The battery becomes part of the car itself, not the pack inside the car, not something bolted underneath, but the structure of the vehicle, the floor, the frame, actually stores energy. And here is the surprising part, this technology already exists, is being researched seriously. It could dramatically reduce EV weight, increase range, and change how cars are built. Yet almost nobody is talking about it. Today I want to explain this about the structural batteries calmly, clearly, without hype. By the end of this video, you will understand why EVs are so heavy today, how structural batteries could solve that problem differently, which is why this approach might matter more than faster charging, and why it's not yet in your next car. Let's start with a reality. Most EV marketing avoids electric cars are heavy, very heavy. A large EV battery can weigh around anywhere around from 500 to 700 kilogram. That's not a flaw, it's physics. But here is the problem, that battery doesn't help the car structurally. It just sits there. The car still needs a separate chassis, floor, and reinforcement. So EVs are carrying a heavy battery plus a heavy structure to support it, which creates a loop. More weight needs more battery adds more weight, which needs stronger suspension, brakes, tires. This is why EVs are getting heavier every year. Efficiency gains are slowing and range improvements are becoming harder. And this is exactly where structural batteries enter the conversation. Let's define it simply. A structural battery is a battery that stores energy and carries mechanical load at the same time. In a normal EV, the battery is like a luggage, the car carries it. In a structural battery, in a structural battery design, the battery is the floor, the battery is the part of the structure. Think of it like this, instead of battery plus chassis, you have battery as chassis. This means fewer redundant materials, less dead weight, and better use of space. From an engineering point of view, this is extremely elegant, but it also introduce new challenges, which we will get to. Let's talk about the benefits calmly, not exaggerated. Massive weight reduce, massive weight reduction. When the battery replaces the part of the structure, you remove duplicate material. You reduce overall mass. You improve efficiency automatically. Lower weight means lower range, longer range, longer range, better handling, less brake and tire wear, smaller motor and cooling systems. Secondly, range improvement without bigger batteries. This is important. Structural battery doesn't magically store more energy. They improve range by eliminating wasted weight by making every kilogram work twice. This is very different philosophy. Just add more battery cells. Number three, simpler vehicle architecture. Fewer parts, fewer layers, potentially lower manufacturing complexity long term. This could matter more than raw chemistry improvements. If this sounds good, why isn't everyone talking about it? The answer is simple. Structural batteries are hard. Challenge number one, safety. A battery that is a part of structure must survive crash, deform predictably, protects passengers, and remain electrically safe. That's much harder than protecting a sealed battery pack. Challenge number two, repairability. If a battery is the structure, how do you repair damage? How do you replace sections? What happens after serious accident? These are not small questions, right? Challenge number three, manufacturing maturity. This technology requires new materials, new testing standards, new factory processes. Automatic companies move slowly for a reason, safety and reliability. So, while this tech is promising, it's not something you rush. This is where people get confused. Structural batteries and solid state batteries are not competitors. They solve different problems. Solid state batteries focus on chemistry, safe energy density, safety at the cell level. Structural battery focuses on architecture, weight efficiency, and system level optimization. In fact, the future might combine both advanced chemistry plus structural integration. That combination could be truly transformational, but it's still years away. Let's be realistic. You will not see full structural battery EVs next year or even in the next 2 to 3 years. The most likely path look like this. Partial structural integration, structural battery modules in limited areas. Gradually expansion as safety data grows. This is a long-term technology, not a headline gimmick. And that's actually a good thing, right? And even if you never own a structural battery EV, this matters because it shows where industry is heading. Weight reduction is becoming the real battle. Architecture matters as much as chemistry, and every progress won't come from one magic breakthrough. This is how mature technologies evolve quietly, incrementally, and intelligently. Let's summarize calmly. Structural batteries won't replace today's EVs overnight. They won't solve charging anxiety tomorrow, and they won't be cheap or simple at first. But they represent a fundamentally smarter way to think about electric vehicles. Instead of asking, how do we fit more battery? They ask, how do we waste less? That shifts might matter more than any single chemistry breakthrough. I genuinely love your thoughts. Would you trust a car where the battery is a part of structure? Or does that feel too risky right now? Let's talk in the comments. And if you enjoy calm, engineering based explanation of future car tech, consider subscribing. In the next video, we'll talk about why EVs keep getting heavier and why that trend can't continue forever.